we can use Le Chatelier's to explain buffer action. So right at the top we've got our Henderson-Hasselbalch equation. Now this is the set of circumstances that we've got. We've got an acid buffer, and we're going to add a small amount of H+. So inside of the solution you've got your acid, and that acid is going to dissociate into H+ and A-. Now to make the buffer we're going to have a huge amount of this, we're going to have a huge amount of this, and we're going to have a very small amount of this, which links back to our Henderson-Hasselbalch equation here. So we can use Le Chatelier's principle to explain what happens to all of these factors when we add extra H+. So what happens is we increase by increasing the concentration of H+, by adding H+, the system opposes the change, Le Chatelier's, and it moves the position of equilibrium to get rid of the extra H+ added, so it moves it to the left. So it decreases the amount of H+ back to what it was before this was added, but by moving the position of equilibrium in this direction, the concentration of A decreases by a small amount too. By moving to the left, the HA concentration increases again by a small amount. And because we're only changing these huge values by a small amount, the ratio in essence changes very, very little indeed, and as a result the H+ concentration changes very, very little indeed, and as a result of that there is very, very little change in pH.